The goal to reach self-sufficiency in the production of oil, as well as the existence of long-term service provision contracts with platform operators, flexible line launching boats, and mooring boats, led Petrobras to develop a culture geared to anticipated production in such a way that the equipment had to be installed as quickly as possible, with the goal of opening a workfront for the platforms and boats already hired, and therefore anticipate production schedules. Due to the distance of our basins from the other oil-producing areas in the world, Petrobras had to create its own engineering solutions for the subsea hardware installation of equipment at the seabed. The method for installing underwater equipment through pendulous movement was the solution found by Petrobras to meet some of its needs, like high costs of mobilization, operation, and demobilization of specific boats. In order to ensure the success of the method, numerical simulations and ocean tank tests with different scale models were developed. For a field test, a dummy manifold was designed and built in full scale in order to validate the mathematical models and increase the numerical analysis reliability. To qualify the installation procedure, the dummy manifold was designed and built in such a way as to reproduce all hydrodynamic inertia, as well as the center of gravity and the center of buoyancy of the P52 manifold. The full-scale test also had the goal of qualifying the installation procedure and certifying the configuration of lifting slings and installation slings, as well as recording all of the movements and accelerations acting in the manifold during the pendulous installation. For the analyses and simulation of pendulous installation, the commercial software Orcaflex and the Situa ProSim software were used. The Situa ProSim have been developed by Petrobras with copy UFRJ, Rio de Janeiro Federal University. Since the BGL-1 does not have a DP, Dynamic Positioning System, another system developed by Petrobras for the mooring of FPSOs, known as SPI, Integrated Positioning System, was used on this operation. The crane barge BGL-1 was kept in position with the help of 3 AHTS, one of them equipped with a DP system. With the SPI system, all vessels involved in the operation are featured on the screens of microcomputers, allowing the manual or automatic control of the boats with total safety. The arrangement of the slings for the test with the dummy manifold shows basically two main types of slings: the lifting sling and the installation sling. The lifting sling is used to transfer the dummy from the deck of the BGL-1 to initial position for release from the crane barge. The lifting sling is made up of chains to dissipate the energy stemming from the 280 tons from the instantaneous release of the dummy manifold, avoiding the impact on the BGL-1. The installation sling is the sling that will describe the pendulous movement, so that the manifold will overcome the resonance zone. The installation sling is made up of a section with 65 meters of wire rope with flotation devices and 1,600 meters of fiber rope. The section of wire rope with flotation devices has the goal of avoiding the initial instability of the dummy manifold after its release. The fiber rope has the goal of reducing the total installation load because it is much lighter. The release of the dummy manifold for the start of the pendulous movement of installation was carried out by cutting the strap of polyester with a wire rope by friction. Since the ROV does not have enough speed to follow the dummy manifold during the pendulous movement, we have included these images of the test in the ocean tank with a scale model in order to show what happened after the release of the dummy manifold. After the superdampened pendulous movement, the dummy manifold was positioned at the seabed as planned in a water depth of 1900 meters, thus confirming the feasibility of installing the real manifolds and validating all of the analyses undertaken and the mathematical models adopted. With the pendulous installation method, Petrobras has overcome one more challenge and will be able to reduce the installation costs of equipment in deep and ultra-deep waters without the need of special winches and motion compensators.